Okay, practice E. We're going to look at number 1. Oh, they made this really easy for you. A projectile is fired at such an angle that the vertical component of its velocity is 49 meters per second. So when I write my given, and I have my x and y given, I'm always going to write ax is 0 and g is equal to negative 9.8 meters per second squared. I also want to draw my picture of what's happening. So it's this type of projectile. This is VI, but they're actually giving me, instead of giving me VI at an angle theta, they're giving me VIX, and they're going to give me VIY already. So they say that the vertical component is equal to 49, so VIY is equal to 49, and then the horizontal component, VIX, is equal to 61. So this problem's easier because they already gave you VIX and VIY. Now, what else do I know? Well, I know from here to here, the vertical displacement is 0 because it's back to where it started. Now, what do I want to find in this problem? Well, I want to find A, how long is it in the air, T, B, what horizontal distance does it travel, X, and C, what is the initial velocity, VI. So we have a bunch of things we want to find.
You would just use the starting exam to find VI, right?
Well, we're not doing that. We're going to do it in order. So what we're going to do first is we're going to find the time. So the total time is from here to here. Now, normally I look at where do I have 3 things. And if I use these 3 things, so I'm going to show you this on the side. Doing it this way, I would have to use the quadratic equation. So I probably don't want to use the time that way, but I'm just going to show you because it's also correct. Remember, in physics, there's more than one way to do a problem. So if I said I had little g, I had VIY, and I have y, and I want to find t, I would use the equation y is equal to VIYT plus 1/2 GT squared. This was 0. VIY is 49t plus 1/2 negative 9.8 t squared, so I have 0 is equal to 49t minus 4.9t squared. Now I could do this, and I could solve for t. But let's look at an easier way to do it, okay? When you look at this projectile, okay, and let me just do this on another piece of paper just to show you so I can explain it clearly. When we do this, okay, when the projectile goes like this is VI, and this is VF. Now, we don't take air resistance into consideration. So remember, this is going to be VIX, and this is going to be VIY. This is going to be VFY, and this is going to be VFX. Now, remember before when we proved that remember the other day we said VFX is equal to VIX plus AXT, but because AX is 0, we showed that the horizontal component of the velocity is constant. Remember, that never changes? Well, the same thing is going to happen here. But the vertical component of the velocity, VFY and VIY, they're equal in magnitude. The difference is, what do you notice? They're opposite in direction. So whatever VIY is, VFY is going to be equal in magnitude. So magnitude means how much, the number in the unit. The difference is they're going to be opposite in direction. So let's go back to this problem. I'm going to look at that same equation Applied vertically, VFY is equal to VIY plus GT. So if I know that VIY is 49, that means VFY is equal to negative 49. So does everyone see why that's negative 49? Okay. So now when I rearrange this equation, I'm going to have VFY minus VIY over G is equal to T. So when I substitute in my values, VFY is negative 49 minus VIY, which is positive 49, over G, which is negative 9.8. So I'm going to end up with negative 98 divided by negative 9.8, which I don't need a calculator for, right? And the negative in the numerator cancels with the negative in the denominator, and 98 divided by 9.8 comes out to be 10. So T is equal to 10 seconds. So the point that I want to make is, for this problem, you can find the time this way, or you can find the time this way, and you're going to get the same answer. If I factored out a T here, which again, you can't do that in math class, and I said 0 is equal to 49 minus 4.9T, and then I rearrange that, I would get 4.9T is equal to 49, and T would come out to be what? 10 seconds. I would get the same thing, okay? But if you do it this way, the only thing is when you use this equation, you see you have to be very careful here. Negative 49 minus positive 49. So be careful with your signs. Now remember, time is scalar. So if it's 10 seconds here, the time is also 10 seconds here. Okay? Now I want to find x. So I want to find x. I have VIX. I know T. I also know AX is always 0. So I'm going to say x is equal to VIXT. And you don't have to write the 1/2 AXT squared, because we know this term is always 0. So our equation is x is equal to VIX times t. The reason is, remember, for projectile motion, these aren't brand new equations. It's the same equations that we used before. The difference is that this equation is being applied horizontally, so there's no horizontal acceleration. We're not memorizing a new equation, okay? So now I'll substitute in my values. VIX is equal to 61 times 10 seconds. Again, I don't need a calculator. The second in the numerator cancels with the second in the denominator, and I come up with 610 meters. Now for the last part, if you're not sure, you draw your picture. They want to find VI. So VIX looks like this. This is VIX, which is 61. From the head of this vector, I do the tail of the other. This is vertical. VIY is equal to 49. From where I start to where I end up, this is VI. And then here, don't forget, velocity is a vector quantity, which means it has both magnitude and direction. So in order to find that, this is obviously a right triangle, so I can use the Pythagorean theorem. So I can say that VI is equal to the square root of VIX squared plus VIY squared. So VI is equal to 61 meters per second squared plus 49 meters per second squared. And then when I do that on my calculator, 61 squared plus 49 squared equals square root, comes out to be 78. So VI is equal to 78 meters per second. But a vector has both magnitude and direction. When I find the direction, I measure from the tail of the resultant. So some of you are thinking, ooh, I forgot to do that on the quiz. So when I find the direction, well, it's good to use the information I know. This is opposite and this is adjacent, so I'll use tangent. So tangent theta is opposite over adjacent, which would be 49 over 61. So again, on my calculator, I would say 49 divided by 61 equals second tan, and it comes about to be 38.7 degrees, so I'll just say 39 degrees, and I'll just say from the horizontal. And that's my direction. And that's it.